Hey, this is Nicolosi, and in this video I'd like to showcase improvements made to the digital delay module. It now has a sublane, which means you can process the delayed signal all sorts of ways. Here I have a logic procession running on macOS with Mela inserted as a audio effect here, so we can have arpeggiated sequencer uh, playing these chords and followed by a multiplug factory preset loaded as an instrument. And this is what it sounds like. Now let's focus on the digital delay module, and it's right here. And first thing you'll notice is that interface looks quite different. It gained a delay path sublane here, and also the feedback and mix have become sliders for easier control. And of course you have different modes here still, and the timing controls are here. And what happened is that this is the unmodified multiplug preset, and it automatically migrates the preset by adding clipper and band pass modules as sublanes, and it migrated these values as well. So digital delay used to have a built-in one-pole low-cut and high-cut filters, and now instead we have a band pass module which offers low-cut and high-cut filters, and so the preset will sound the same as before. It just has a more flexible layout. Another thing the digital delay has, it has a built-in hard clipper to prevent feedback getting out of control. For example, I'll increase the feedback and you'll see what happens. Sound gets more and more distorted. You could use this feature creatively, but most of the time it's a sign that you want to adjust parameters in feedback path in such a way that the feedback doesn't get out of control. And to creatively let you distort, still, the updated clipper module has been also inserted, and this mimics the settings of the digital delay. Internal hard clipper is set to plus 6 dB fs. But if you don't want to trigger that internal hard clipper, you can set this to a low value, and it will trigger this clipper. And you can also change it to soft clipper, for example. And let's see how that works. So in this case, we use the soft clipper, and it gives us a slightly different sound. And this indicator lights up that lets you know the peak has been reached. So you can use that as a way to control the levels. If you don't want to hit that clipping limit, you can always decrease feedback or have some settings in a feedback path that ensures the feedback doesn't build up continuously. Okay, so we have this bandpass filter. We can change it to 2-pole, for example. But again, we don't have to keep this at all. We can just remove it or replace it with, say, a VA filter. And maybe I'll make a resonance filter here. And let's see what this sounds like. And like I said, you can insert anything. So this includes an envelope follower, and we can modulate the frequency of our filter here using the envelope follower. And let's see what that sounds like. Let's make this fast acting. And we can do something completely different as well. If we let's remove these, and what I'm going to do is I'm going to insert a MIDI input, and then let's convert it to a pitch signal using note pitch, and I'll insert a video oscillator here. The pitch of this oscillator will look to the MIDI notes coming in, and I'll set this ring to 100%. So what this means is that our delayed signal will be ring modulated using the sinusoid matching the pitch of the input signal. So actually, let's change this to stereo mode and let's hear what this sounds like. But I think this will sound a bit more interesting with MIDI transposed up an octave or two. So let's add a transposer and set this to 2, maybe add back bandpass to control the high end. As you can see, digital delay is now very flexible with the ability to process the delayed signal in any way you like. This is a feature I've been wanting to have a long time, and it's finally here. So I hope you also enjoy it. If you have any questions, leave a comment below, like and share if you found this useful. Thank you, and see you next time.